Antonio, hi.
Hi.
Hi, Antonio, where are you right now? Love to know.
Yeah. Now we are in Milan.
You're in London?
Yes.
Fantastic. Right, so direct from London. You know the score. You have 3 minutes, no more than 3 minutes to share your big idea. Are you ready?
I'm ready.
Okay, 3 minutes is yours.
Okay. Thank you so much. I hope you can see. Okay, our light is not a simple paint. It's a technology which transforms your surfaces into a natural air purifier. As you know, pollution is one of the biggest threats to humanity. It's very dangerous. And we spend a lot of our time indoors, so the air quality indoor is a big problem. Our light is a solution which uses the light of the sun to transform pollutants into mineral salt. It uses the same technology as a solar panel, and it comes in a form of a colored paint, which is used both in architecture, but also combined with materials like as in car. This was a 500 electric cars which we presented last year. The properties of the product are very much, it reduces air pollution, it eliminates viruses as well as COVID-19, fights bacteria and mold, repels dust and dirt, and reduces cooling costs in architecture components because of the reflection of the heating part of the air, of the light of the sun, and also reduces bad odors. It does by ionizing. We use the photocatalytic effect, which transforms photons into electrons. Those electrons combine with water and oxygen in the air to make ions. Those ions makes all of that. It is also a very low carbon product. It has a much less CO2 than any other paint. We can say that we have like 72.7 lower CO2 footprint than any traditional paint. The market is very big, both for architectural paints and air purifiers, and we are very focused on work with that. We have now some very good customers in different fields, just for this channel advantage of sales in real estate, and also as a social messages, which we do a lot of communication with partner and customer around the world. The company has already did some traction. We did some funding over the years, which we use it for R&D and market startup. We are now going into commercial. We just have more than 1.5 million of square meters covered and more than 20 partnerships. And we also went to a lot of award and press, because actually a paint which kill pollution is such a good product which has to be developed, but already has get some traction from the market. We have a good team which works in Italy, Switzerland, and UK. And the way we work to us, if I can say, is that we are now setting to put ourselves as a new standard.
Antonio, I have to jump in, I'm afraid. Just to make it fair and square for absolutely everybody. 3 minutes. Antonio, fantastic. Well done. Sharing your big idea. Again, what happens now is we move over to our jury members to find out exactly how they felt about what they've just heard. So I believe, Karl-Heinz, you have a question for Antonio.
Yes, sure. Thank you very much for your presentation. And I have one or two questions for you. Are there any limitations for the material you coat? Meaning in our cars, we are not looking on the outside, but also maybe this is interesting for the inside, where we have plastic, leather, or textiles. That's one question. And the other question is that coating, is it for lifetime, or is it somehow limited by durability? So does it disappear after a while?
Yes, we can work also on plastic, textile, also synthetic leather. We did some tests also with Alcantara where we have very good properties. And we have a transparent one which can be used on plastic materials, on metals. The durability in the architectural product is we give a warranty of 10 years, but the properties are lifetime. There is no reduction in the properties. In interior product, where they can be stretched or used because you sit on it, eventually there will be a lower durability, but it's in the size of a couple of years, 3 years, and things like that. We are doing a lot of tests also with manufacturers to increase the properties, because it's also a combination of different parts when you go into some specific material.
Okay,
A little bit more time, 15 seconds for a quick question. Okay, I'll take that as no, and everybody's satisfied and happy with what they've just heard. Antonio, thank you so much. We'll hope good luck, and let's see where you end up. Perhaps we'll see you again tomorrow as one of our lucky 3 winners. Right. We move on slightly, but before we do, again, we've noticed in the chat, it's great, we have people from, naturally, Paris, moving across Lyon, Marseille, but we're also going across to Luxembourg, Taiwan, I believe. We have people from Uruguay, I think South America as well. So many people indeed. And keep letting us know how you feel about what you just heard. Again, the jury members, they decide the destiny of who the winners are, but let us know how you feel. And I believe we've got lots of messages in Turkish. We can't understand those, but keep them coming, whatever they mean. I hope they're all positive. I'm sure they are. We move on to our next finalist, our third finalist of the Startup Booster 2021 competition. And that is, so we started in Switzerland, we went over to the UK, now we go over to Germany for HCPI transfer, and we have Philip Götz on the line, I believe. Philip, are you with us?
Yes, I'm with you.
Wonderful. And where are you, Philip, right now in Germany?
I'm calling from Dresden, Germany. Yeah.
Okay, wonderful.
In the east.
Wonderful. Yeah. You know the score. You know how it works. We know how it works. And we want to hear what you have to say. So are you ready?
Yes.
Wonderful. 3 minutes is yours.
Perfect. So I'm just waiting for the pitch deck. Oh, yeah, a little bit too far already. Good. So, yeah, this is my pitch for Team HPCI. And I have quite a controversial statement in the beginning. I say conventional joining technologies like gluing, screwing, or riveting, you can throw them into the trash can. With us, you save time and money. With our HPCI joining tool, you save time and money and increase your joining performance. Where's the problem? In the middle, we have our production engineer, for example, at Airbus, Magma, or Daimler, and he actually just wants to join part A with part B, for example, for a hybrid part, to get an optimized design and a functional component. But he always has very long joining times and needs an additional material. We see that as a bottleneck when we compare the cycle time of a Volkswagen Golf 7 to a BMW i3 with a factor of 6. So he always makes a compromise with adhesive bonding. He has a long joining time, and with mechanical joining, he has to drill a hole into his precious composite. And yeah, that's not a nice design and not very load efficient. We have the perfect solution for that. Our HPCI technology and the HPCI tools make it possible to join completely new materials and material combinations with a higher strength. And more importantly, you have a minimized joining time of just a couple of seconds, and you don't need any additional material. We are offering the technology know-how, the joining tools, and also the necessary pre-treatment. The technology itself is quite simple. It's only 3 steps. You have in your initial state your fiber-reinforced plastic or non-reinforced plastic and a pre-treated metal. In the second step, you press them both together, heat it up locally by induction. The polymer melts, flows inside the metal structure, and after a short cooling process, the polymer resolidifies and you have a strong connection. Let's see how this looks like in reality. Here the example of aluminium to a glass fiber-reinforced 6 sheet. We just place the parts loosely upon each other. Then we have our prototype Mark I HPCI joining gun, which moves to the parts, presses them together. The red part is a small induction coil. The heating process has already started and is already finished now. We can take the part out and put a substantial mount amount of load onto it. Here even the metal breaks and not the joining zone itself. We have tested this for all types of metal-plastic combinations like mild steel, aluminium PP, and titanium CF PEEK. The market is everywhere where hybrid parts are found, automotive, aerospace, industrial equipment, anything like that. And this is an enabler for the composite industry through easier integration of composites in hybrid designs.
Philip,
Yeah.
I have to jump in there. I know it feels brutal, but it has to be fair. So it's brutally fair. Let's say that. Thank you so much.
That's
Wonderful.
fine.
But again, these are the moments now where we find out a little bit more exactly underneath the bonnet, as it were, about your idea. And I believe Johannes, you have a question you'd like to ask Philip right now.
Yeah, Philip, thanks for the real interesting presentation. Question from my side is regarding a combination out of thermoplastic and metal. There was always a little bit creep involved and, let's say, temperature differences between aluminum or plastics and metal. Have you looked into that, and is that an issue or
pendant les questions, il me voit.
Yeah. Sorry, I have double noise here.
Yeah,
we have looked into that. We have done aging tests according to PV 1200, for example, and PV 129, and yeah, we see a small decrease of the strength, but this is mainly due to the behavior of the thermoplastic itself. So by using our special laser structure we apply before the joining process, we can overcome this delta alpha problematic and have age-resistant joints that are also media tight. So, for example, for like you said in the beginning, for battery components, we have done some tests with an end user, and we can say the joints are media tight and are definitely very useful for battery components or for electric components.
Okay, good. Thank you.
Thank you.
Is your solution only limited to thermoplastic, or can you also do thermoset? I assume no. And what is your quality concept? So how do you prove that the I think it's a weld line is okay?
Yes. So regarding thermosets, we need another layer of thermoplastic in between to join thermosets. So we cannot say we don't need any additional material when we come to thermosets. So, but we have done tests with, for example, CFRP and then a small layer of PEEK foil in between, and then we were able to join metal to thermoset with this small help of an additional thermoplastic layer. And the second question regarding quality assurance. So normally we do this by destructive testing, but non-destructive testing, we have some solutions regarding flash thermography. We have tested this, so we can also say we have some solutions for non-destructive testing, but mainly we do destructive testing at sample parts.
Okay, that wraps up our 2 minutes together with you, Philip. Philip, thank you so much. And again, I don't know, the jury members don't know altogether yet, but we'll find out tomorrow whether we see you again in the final as one of our finalists. Thank you so much. Wonderful. Okay, as you can tell, as we go through our big ideas, it gets harder and harder, not just for the jury members to decide who these lucky winners are, but for you as well. So again, keep it going. If you've just joined us, remember this is the Startup Booster 2021 Startup Competition, listening to the first 10 big ideas, next 10 a little bit later on at 5 o'clock, and then tomorrow we'll find out who the 3 lucky winners are walking away as winners of this year's competition. Right, moving on. As I say, we already started in Zurich, we went to the UK, went to Germany, and now we move across a little bit further away. This is a bit further away, over to Russia. I believe we have the winner of the JEC Startup Booster JEC Asia competition from 2019 with us right now, and that is Anisoprint from Russia. Fedor Antonov, are you with us?
I'm with you.
Hi, nice to see you again. Lovely to see you. Right, how are you feeling? Are you ready?
Yeah, I'm ready.
Always ready. Over there. How's the weather there in Russia right now? Where are you in Russia, by the way?
I'm not in Russia. I'm in Luxembourg, actually.
Okay. Just pretend you're in Russia. It sounds good. Fine. It sounds good. Right. Okay. Fedorov, I think we're ready here. You're ready there. 3 minutes is yours.
Okay. Thank you. Hello, my name is Fedor Antonov, and I'm CEO and one of the founders of Anisoprint. At Anisoprint, we bring a new globally demanded manufacturing technology with a focus on lightweighting and sustainability. We use composite materials with the best performance to weight characteristics to 3D print optimal parts with zero waste, single stage, fully automated, low energy process. So lightweighting is the key trend in manufacturing, and composite materials are the best candidates for lightweight applications. Because these materials have extremely high performance due to their anisotropic nature. They are made from fibers that are directional and made up with orientation of molecules. Today, we use anisotropic material without properly respecting the directional properties. This locks down the potential of composites. So this is the wrong way, as you see on the picture now. There is a different way to design composite materials with anisotropic lattice structures inspired by nature and engineering history. For example, a Boeing Dreamliner was designed with an old black aluminum approach, which is already obsolete, and while an Airbus A350 concept, which I really like, represents a much more optimal lattice design approach. Optimal composites are made with respect to their directional nature. Such structures are designed in a way that the material directions are matching loading conditions in every part of the structure. Such structures can be designed with topology optimization and mostly represent curvilinear lattice structures which look very bionic. And that's the true composite. To make such structures, we need maximum freedom and maximum flexibility with minimal limitation to allow different materials to be printed with different fiber content, full control of fiber direction, and capability to manufacture lattices. This is what we call anisoprinting, a manufacturing technology that allows to create optimal composite structures. Currently, anisoprinting is implemented within software, hardware, and material products, together allowing the production of optimal composite material parts with respect to material anisotropy. The market for such lightweight solutions is rapidly growing. Today, we can use this technology to 3D print mechanical parts and tools, and in a few years, this will help us to replace metals in the majority of applications for aerospace, automotive, mobility, robotics, and healthcare, and further on. Here are a few examples of already printed parts for different mobility and robotic applications, which help to significantly reduce weight, cost, and waste. So we offer this full solution with software, materials, and hardware in both desktop and industrial format to cover this demand. We are an international company with offices in Luxembourg, Russia, and Japan, and growing 3 times from year to year since 2019. Anisoprint is an engineering-focused company with over 20 engineers and researchers with a very strong background in design.
I'm going to have to jump in there. Yeah. I'm so sorry. I know how that feels, but it has to be fair and square for everybody. And thank you so much for your pitch and sharing your big idea with us. But let's hear now how big an idea it was in the hearts of our jury members. I believe Marcus, you have a question for Fedor. Marcus, I believe you have a question.
Yeah, what would be what would be your primary application that you are targeting market side? Is it aerospace industry or automotive industry? Where are you most active at right now?
So it's actually step by step. We have the desktop products with which we mostly focus and cover the demand in tools, jigs, and fixtures, and spare parts and R&D functional prototyping applications. And of course, we are with our new solutions with industrial systems. We want to focus on industrial applications, and that's of course mostly aerospace and the growing markets of aerial mobility, so UAVs, drones, robotics, and urban mobility. And there, of course, the main barrier, you know that it's the certification, and so that's why we are approaching it step by step.
Great, thank you.
We've got another 60 seconds on the clock.
Yeah, okay. Maybe I ask a question. What is your differentiation, again, versus the competition? Because there is others that have the same solution, more or less. Until now, we have not succeeded to find a solution that is what you're just showing, yeah? So a bracket, a high-loaded bracket with that technology. So what doesn't make work in your solution?
Okay, so yeah, for us, the main value is the flexibility. So we are developing the technology which offers the maximum flexibility, which is really capable of producing complex shaped structures, focusing on lattices and fiber steering. So really optimizing the fiber direction in every material point and making like real optimal topology optimized design with curvilinear shaped lattices, which give the maximum structural performance. So that's the main difference. So we are trying to bring the most flexible technology, which actually can print these lattices, and this is sort of a unique feature on the market, both in terms of design approach and the manufacturing capabilities of the system.
Fedor, thank you so much. So thanks again, and hopefully, I don't know, fingers crossed, we might see you walking away a winner tomorrow. Thank you so much. From Russia via Luxembourg, but nobody knows. Okay. Right, we are moving through these great big ideas very, very quickly and quite swiftly as well. It's getting tougher and tougher. Again, let us know how you feel about what you hear in the chat. To hear your opinion of what you hear as well. We move on now to our next startup, next finalist through the competition. Finalist number 5. We've just been to Luxembourg. Now we jump on a plane and we go south to Spain. So over to Spain, and I believe we have B Circular and the CEO Oriol Grau. Oriol, are you with us? Are you with us, Oriol?
We are in Barcelona.
Right, you're in Barcelona. Spain. Wonderful. Yeah. Barcelona, feeling good. Barcelona's feeling good. You're feeling good. We're feeling good just hearing that name, Barcelona. Right, Oriol, are you ready? Have you got everything ready for us?
Yeah.
Wonderful. 3 minutes is yours.
Perfect. As you know, composites are considered one of the materials of the future. They have excellent properties and they are used in several sectors. But composites have an important drawback. It's almost impossible to recycle this material. And that is a huge problem because circular economy has been activated by European Commission. And nowadays, more of 90% of composites are stored in landfills. My name is Oriol Grau, CEO of B Circular, and we develop advanced materials from composite waste. We have developed a disruptive, efficient, protected, and clean technology able to recycle composites. Our business model is based in waste management and product sales. We can recycle all kinds of composites, carbon and glass fiber, and final products or scrap. But we are focused in aeronautical, automotive, and scrap of different industries. Our technology can obtain high quality fibers from waste with 0% resin. With this fiber, we can produce thermosets like non-woven or fabric with high performance and aesthetic properties. And we can produce thermoplastics. In this case, the high quality fibers are used as reinforced polymers. And we can multiply the properties of the polymers. For example, in PP, we can multiply by 9 the original stiffness, and we can triple the resistance of these polymers of the origin. We can use these thermoplastics to produce 3D filaments with high performance, aesthetic properties, and all characteristics of 3D filament or 3D industry. We have a high quality qualified team with extensive experience in different areas, with marketing, engineers, fiscal and management, and chemists. We have the support of different entities like European Commission and entities from Spain and Catalonia, and we obtain different national and international recognitions. And thank you very much.
Thank you so much, Oriol from Barcelona, sharing your big idea. Right, let's hear from our jury members about what they feel about what they've just heard. So, Johannes, I believe you have a question for Oriol.
Yes, I have. Thanks, Oriol, for your great presentation. I have actually two questions. One is regarding volume from this recycled fiber market. I'm working in the automotive industry, so is there enough recycled carbon fiber for, let's say, high volume production, or is there a certain limit, and how do you get around that? And then the second one is regarding your basic business model. Are you gonna develop, are you only focusing on the recycling of the fibers and give them to future material suppliers to compound that in their material, or are you really looking into a new material you will finally produce and supply?
Okay, I'm going to start with the second question. Our business model is based in management and the waste, or this kind of waste. We are focusing carbon fiber. It's true that we can recycle glass fiber, but really we want to produce advanced materials, and for this reason we want to recycling carbon fiber first. In glass fiber, they have a huge problems in different industries, where, like nautic and wind blades industry, they have a problem nowadays, and there are a lot of companies that you are using. Nowadays, we have different partners to develop composites and develop compound to make these pellets. We want to do this work in the own company, but nowadays we are started and we need the collaboration with other partners. So we want to do both parts. The selling products, because it depends on the materials we are producing we are producing in the company. We can make resins and vacuum resins, infusion. We can do that, and we have a 3D printers.
I'm just gonna stop you there, Oriol, only because of time. Just to make it fair and square for absolutely everyone. Oriol, is it sunny in Barcelona? I have this image of it's really sunny in Barcelona. Is it sunny?
Yes.
Right. Okay. So
yes.
Sunny Barcelona. Thank you so much, and good luck. And maybe we'll see you as a winner tomorrow at 2:30 when we announce the winners. Thank you so much. Wonderful. Right, so we've heard 5 of the 10 finalists in this section. So if I was to ask you, those of you that are listening to us, that are beaming into us around the world, if I ask you now, which winner, out of the 5, which one would you choose as a winner? I'm just actually asking this, and we would love to know from the people that are beaming in. Nothing to do with the jury members, nothing to do with the decision that our jury members will take. But if you had to choose one, who would you choose? Love to hear. Pop it in the chat and let us know. Right. We move on to our next finalist. And so sunny Barcelona, we go right across to a place which is quite popular in the chat right now, Turkey. So I believe we have JEC Composites and the co-founder and the CTO, Burcu Karatsa Ugoral. I'm sure I said that wrongly. Did I say it correct or wrong?
So.
That means it was completely wrong. That's okay. Right. Burcu, are you ready? Are you ready to share your big idea? You look ready. You sound ready. I can see your presentation's ready. It's over to you. 3 minutes.
Okay, thanks. Hi everyone, this is Burcu, co-founder and CTO of JEC. Natural fiber composites are promising materials for sustainability and low carbon manufacturing. I guess we all agree on this, but they don't go mainstream, especially the ones with high performing and thermoplastic based ones. I mean thermoplastic UD prepregs. So there appears 3 problems actually: high prices, industrial scalability, their limited scalability, and reliable performance. In fact, these problems arise from the manufacturing approach, how the natural fibers are aligned or the polymer is impregnated. Here you see the current method. UD fabrics are used to align the fibers, but the UD fabric production is a multi-step process and also brings some limitation in width. And the UD fabrics are either covered with powder or film under high temperature, under high pressure, or impregnated with polymer melt via inline extrusion, but they need sizing chemicals. So the current method, we can say, is a very complex and costly due to having several steps and requirement of labor, energy, or chemical intensive processes. What we do is we simplify the whole process with our patent pending method. We produce these UD prepregs from natural fibers directly from our special yarns, which includes the natural fiber and the thermoplastic polymer inside. So we don't use any UD fabric, film, powder, or melt polymers. So we skip the UD fabric production steps and also the complex steps in polymer impregnation, which means there is no more add-on cost or technical limitations in scalability. We offer Ecorain, our novel product name is Ecorain, and this is the lowest and the minimum unit cost product in the market, thanks to our patent pending technology. While with UD prepregs will enable industries to go mainstream with mass production, and the narrow UD tapes will pave the way for adapting automated tape laying systems or tape weaving system and even 3D printing systems for the natural fibers. And all the cut-off base can be used as raw materials for injection molding just by simple grinding method. And actually, I invented the method and the product during my PhD, and I feel so lucky to have this amazing team with me making this invention and industrial reality. We have a team mix of mechanical engineer, polymer engineer, IP-based technology commercialization experts, and also agrotech woman who is leading our flex production in Turkey. So what we believe is we can be a stakeholder in go green strategy of mainstream industries. So develop us in. Support us developing our natural fiber composites.
I have to jump in. Will you finish? Oh, you were finished. Just a couple more seconds and you were finished. Wonderful. Thank you so much, Burcu, for your big idea, sharing your pitch right now. Let's find out from our jury members once again how they felt about what they've just heard. And I believe, Karl Heinz, you have a question.
Yes, for sure. I have a question. First of all, thank you for your pitch. It was very interesting. And I'm wondering 2 things. Did you make any investigations for the LCA life cycle assessment in comparison to other standard composites? And the other question is, how do your fibers behave under wet conditions?
Yeah, actually, we are still running through some R&D scale, let's say, works. We made the test for the wet conditions, for aging test for the temperature and humidity. Actually, it goes really well because we all changed the impregnation method. So there is no problem with impregnation of the polymer into natural fiber, which helps us to have really good results under wet conditions or with different temperatures. by the LCA analysis, actually we are still working on with the university with us, because it's a very complex process. We need to analyze all the steps. So I hope we will get the results soon. But we are really, we skip lots of steps which will help us in reducing the environmental impact of the production and also the product itself.
I think we've got another 30 seconds on the clock.
Can you hear me? Yeah.
Yeah.
Just a quick question on thermal properties. So if we think about thermoplastic composites, so how high can you go with your fibers in terms of temperature?
We tried with polypropylene, PLA, and polyamide. So we see the limitation is around 230, or we can go even higher if we make additional treatments for the natural fibers.
Wonderful.
Actually, we aim to increase the functionality with this kind of chemical treatments.
Okay, wonderful. We'll wrap it up there. That is the end of our questions from our jury members regarding your pitch. Good luck. Hopefully we'll see you perhaps as a winner tomorrow in the final. Thank you so much and
Hope
goodbye.
So.
Where are you in Turkey, by the way? Are you?
I'm in Izmir.
Izmir. Okay, wonderful.
Izmir, yeah.
Thank you so much. Right, we move across now. So from Izmir, we jump on a plane once again and we go over to, which country shall we go to? Where would you like to go right now? We'll go to La France. We are staying right here in France where we are, well, maybe not in Paris. We'll find out in a second. So we have Carbon Axis co-founder and CTO, Kemi Avila Mori. Kemi, are you with us?
Yes, I'm here.
Fantastic. Where are you in France?
We're in the west coast side of France, in La Rochelle.
Oh, La Rochelle. Okay, wonderful. La Rochelle. Right. You have 3 minutes. You know how it works. I can see your presentation. We can see you. We can hear you. Are you ready?
Yes, I am.
Okay. 3 minutes is yours.
Thank you. What if composite automation was accessible to all industries? My name is Chemi. I'm co-founder of Carbon Axis, and we specialize in providing turnkey solutions that are simple and easy to use. One of the main problems in the composite industry is that parts are still majoritarily done by hand. This is due to complex layups and delicate material handling. As a result, we have high manufacturing costs due to the labor-intensive steps and a lack of repeatability in the process. Most of the current automated solutions are not flexible and have been tailored for the aeronautical industry, making them inaccessible to the rest of the industries. Carbon Axis has developed a compact and accessible AFP solution that we call the XL. The XL is composed mainly by 3 elements. The body of our machine is our AFP robotic cell that allows for a safe operation within a small footprint. The heart of our machine is the X-Place, our lightweight and compact AFP head that with its unique and patented design enables the manufacturing of small parts. We have also developed our own dedicated AFP software that we call the XLay. It's an all-in-one software solution that enables the user to go from part design to robot code generation within one single environment. The XL machine is a production-ready unit that is dedicated to the manufacturing of small preforms. It has the capacity to process thermoset materials and dry fibers, and it allows for flexible manufacturing. We have optional features that can be easily integrated into machines, such as multi-material placement and ultrasonic cutting. Our revenue model is through machine sales and services. We have segmented our market in 3 different categories: industrial customers, universities, and research centers. From preliminary market studies, we have found that there is an opportunity to provide accessible automated solutions outside the aeronautical industry in order to improve part quality and reduce material waste. So how are we getting traction? We currently have 2 machines installed in our client sites. The first one is JEC Composites, a sport equipment manufacturer in France, and second one is Compositadura, a technological platform in France, whom we also have a collaboration agreement. We have 2 machines in the pipeline that will be delivered in the following months, and we are also working with industry partners to validate the technology. Also, we are discussing with different material suppliers such as Teijin and SGL Carbon to develop new low-cost materials for AFP. So how do we do it? We have a very strong and diverse team that is able to develop and integrate all our solutions in-house. What's next for Carbon Axis is we're looking for partners or investors to ramp up our production, and we're also looking for partners to develop new raw materials. So if you're interested to work with us or have more information about our technology, please send us an email.
We'll jump in there, and you made it just a few seconds to spare. Wonderful. Carbon Access. Okay, let's hear from our jury about what we've just heard and how they feel about what they've just heard. And I believe, Thomas, you have a question.
Yes. So thank you very much for your presentation. Back to your value proposition. So I believe you might have a component linked to quality, reliability, and also to productivity. If we think about your industrial partners, what would be their main focus when adopting your technology?
The main focus in our industrial partner has is that they want to automate the production because right now they're using hand layups and it creates loads of errors during their production. So what they want is to have a quality control and a process repeatability. So there's the main things that they're looking, and at the same time, to be able to have it automated, because as we saw, with the pandemic, one of the things that happened, it was the problem was with the supply chain. So what our industrial partners are looking at also is to bring back their manufacturing closer to the consumer.
We've got another, I think, just under 60 seconds now for another question, perhaps, from our jury members.
Yeah, maybe. I have a question. So, if you're targeting low-cost products in your process, the cost of slitting of the material for AFP is quite high. So, do you have a solution for that?
Yeah, this is one of the reasons why we're discussing with different material suppliers, because the slitting tapes are mainly done for aeronautical industry. So we're looking to develop materials that are for low-cost AFP. So we have been in discussion with different material suppliers that they are also interested to start developing new materials. So they're looking into the market right now, and this is the collaboration that we have with them.
Chemi, wonderful. Thank you so much. La Rochelle. Is it sunny in La Rochelle right now?
Yes, it is.
It is, right. Okay, thank you so much. Good luck. And again, maybe we'll see you tomorrow as one of our lucky winners of the Startup Booster 2021 competition. Thank you so much.
Thank you.
Right. As you can hear, it's getting tougher and tougher. I certainly wouldn't like to be in the seat of a jury member a little bit later on when they have to decide who out of these 10 and the next 10 a little bit later on at 5 o'clock, who they're going to handpick as the 3 lucky and well-deserved winners of this competition. All diverse ideas, but all definitely credible and strong ideas, which is why it's so difficult to decide who should walk away a winner. Let's move on now to our next finalist. Already on finalist number 8, our 8th of 10 finalists from La Rochelle. We move over to Switzerland, and I believe we have Compare, the CEO of Compare, Amael Kohades. Is that right? Amael, are you with us?
Yes, I am.
Wonderful. And where are you, we wonder? Where are you in Switzerland?
We are based in Lausanne.
Lausanne, right. La Rochelle to Lausanne, right. Are you? I can see your presentation is ready. You look ready. I can feel you're ready. Are you ready?
Yes, I am.
Wonderful. Okay, 3 minutes. Over to you.
Thanks a lot. Great. At Compare, we extend the lifetime of composites, helping manufacturers, consumers, and the planet. Human beings are able to live for 80 years, but most of the products we use every day last only a few years. This is a paradox, no? And for us, that's exactly how it started, being inspired by nature to extend the lifetime of composite applications. The use of composites is now widely spread across many industries, and even though they are very great, there is a big issue during their lifetime. Small cracks that grow more and more until catastrophic failure. And this is a global problem. Because on one side, people start to repair such kind of damage, and this costs $17 billion per year. But not only that, for many applications, people just replace parts, generating a very high amount of unrecycled waste. This raises big question of lifetime management as well as sustainability. And with Comper, we are bringing the solution to reduce maintenance costs while having a positive impact on the environment. Our solution is carbon and glass fiber textiles that are pre-impregnated with our magic chemistry. We sell those to part manufacturers and OEMs, for example, a shipyard or sports equipment manufacturer, for them to manufacture full composite parts with new functionalities, an efficient and ultra-fast repair, as well as an efficient recycling. To demonstrate the technology, we manufacture several demonstrators, but specifically that one to show that we can manufacture complex shapes at a large scale. We impacted it, and in the middle of your screen, you can see a typical damage. With the traditional patch repair method, this would take many hours to repair it. With our solution, this is simple. We just come with a heat gun, 150 degrees for 1 minute, and it's done. We recover all the initial mechanical properties. The beauty of this technology is that we can have multiple products with one magic chemistry, and we plan to expand our product portfolio to best meet the market needs. With Comper, we can touch the entire composites industry. We have now an industrialized product, the HealTech series, that has been shipped to the first clients into the sports and marine industries. Through the use of standard fiber types, our prepregs are suited for all type of geometries, and the opportunity behind Comper does not stop here, because we are already preparing our next product families for a wide use of this technology within the composites industry. And we just closed our fundraising to secure our market penetration. Our vision at Comper is to provide full circularity to the composites industry by allowing efficient repair and recycling. Such circular economy model has demonstrated the potential to save up to 50% of composite resources, which is totally in line with the UN Sustainable Development Goals. My name is Amar El-Koad, I'm CEO of Comper, and this development directly follows my PhD thesis. Together with the incredible Comper team, we are the perfect combination to succeed and make a large impact with this technology on the market. You have issues with your composites, you're looking for new prepregs or looking for partnerships, get in contact with us on JEC Connect to build the world of tomorrow. Thank you very much.
Amel, wonderful. Right on time, all in time, and a strong, bold pitch as well. Right, let's hear from, once again, our jury members about what they've just heard. And I believe Yele has a question for you.
Yeah, what is the targeted products which you could potentially repair 60 times? It's quite amazing. What is the mechanism? What makes it work? And what is the effect on weight and cost?
Thanks a lot for the question. The effect on the weight does not change because what we are playing with here is the chemistry of the resin, and the resin has a similar density as traditional epoxy resins. And then on the other side, you mentioned the cost aspects. Of course, we are premium products, so there will be an additional price on that. But what we have demonstrated is that with economies of scale, we can be completely competing with really mass production of composites.
Another 60 seconds on the clock.
So what are the first industries you're targeting?
As I was mentioning right now, most of the interesting implementations that we have are into the sports, leisure, and marine industries. It's also because we are young companies, but we are already preparing our next targets, and mainly what we want to grow in is also have some, we demonstrated a lot of interest within the wind industry, for which we have a huge innovation projects that is running, and we have support as well from the European Space Agency within the startup program to already go into a really high performance composites, and we've demonstrated really nice performances out of this program as well.
Amel, thank you so much. Wonderful. So we leave you now here in Paris to Lausanne and around the world. We leave you, but hopefully, maybe we'll see you again as one of our winners. So thank you so much.
Thanks to you.
Right. It's really getting tough, isn't it? That was number 8. We move on slowly now to our 9th finalist. And again, it's not just tough for us looking in, beaming in from around the world to our studio here in Paris, but also for our jury members, our expert jury members who know what they're looking for. They hear ideas all the time. So they're really picking out the ones that really they feel should walk away winners and have the right potential to move forward, certainly within the industry. Let's move over to our next finalist, number 9. And so from Lausanne, we take I think this is more of a long haul flight, so away from Europe, over to Nigeria. So we go over to Nigeria for Green Access. We have the chief strategist of Green Access, Obina Amunadi. Obina, are you there?
Thank you. Yeah, you got me.
I think we can. Are you there? Wonderful. It's looking really sunny to your left. Beautiful weather. We'll hear how beautiful your pitch actually is right now. Where are you in Nigeria, by the way?
I'm in Lagos, Nigeria.
Lagos, Nigeria. Wonderful. Your presentation looks ready. You seem ready. Are you ready?
Yes, I'm ready.
Wonderful. Okay, over to you. 3 minutes.
Yes. So at Green Access, we believe that waste is a resource, and we've been able to do that by creating materials out of our waste. So at Green Access, we take waste materials and manufacture biocomposite materials for the building industry. Though the materials can also be made for the automotive industry, but we focus on the building industry, where we use these biocomposite materials to make biocomposite boards or panels, which are used for ceilings and also be extruded into doors. So the world produces about 2 billion tons of waste, and about the 2 billion tons of waste, this we generate about 3.5 gigatons of greenhouse gases, and these are due to the emissions from the landfills, and only 5% of this waste are recycled. So 70% of this waste we have are actually recyclables, but we tend to throw them up. Even between me and you, we know that we generate waste, and most times we throw it away and have that throwaway attitude. But we want to also tell you that most of those waste you throw are not throw away. They can still be used to create value in our community. So we are focused on the building industry because we saw the large amount of buildings that are coming up in the industry. So here we take out our materials. We take from food scrap to biomass to plastic, hard plastics, and also kitchen leftovers, where we extrude them and produce a composite materials for the building industry. And so that's the process, and it's a competitive environmental advantage. It's a cradle-to-cradle product, and it's climate positive because we take out we use also biomass, which biomass sequesters CO2, so it's cost efficient. And also I want to go to that these materials, everybody generates waste are found everywhere, so we're able to see waste. Sourcing of the materials won't be hard for us to get. So we've done our research, and these are research. We are focused on the building materials market and the furniture market, and also those are our focus areas. And our boards are 30% cheaper and eco-friendly. So we have a team of 4. I'm an environmentalist, an engineer. So I've been doing this, trying to look for the best way to look for the solution to our waste. And we have a material engineer who is also also helping us refine our product. So we're really looking to raise up funds to help us pilot our product and also enter the green construction product, where we'll create less impact on climate change and also achieve great products and create social change in our communities. Thank you.
Obina, wonderful, and in time as well. 3 minutes can last a lifetime for many, and also it could be very quick for others. You did it really well, and certainly on time. Right, let's hear from our jury members about what they've just heard, and I believe Marcus, you have a question for Obina.
Yeah, quick question. You mentioned boards as being the main material, or do you have other products you want to supply to the building industry?
So it's more of, we have boards and we have doors. They can be extruded into doors, but we focused on the doors because they're easier to make, and due to our limitations of what we can or the technology we have at hand. So I'm making boards. On the long run, we intend to also extrude these boards or this biocomposite into doors.
And the material, is it all organic, or is it a mixture of organic material with other waste material?
It's 70% organic and 30% plastic. So why we did that? Because we needed to make this more sustainable product. So even if it degrades, it's able to, even if it's thrown away or there's something that happens in the future, it's able to degrade with the cost of the composite, the cost of the organic material. So we also take food scrap. We can also take bones. We can also take construction demolition waste, that the wood from construction demolition waste, and it makes it easier for construction waste to be used in a new product.
Okay, thank you.
Okay, I think we have another 15 seconds on the clock. No. Okay, I'll take that as. Oh.
What is the structural capability of your product?
So for now, we are not trying to use it for any hard structural building. So what we will just do is mostly used for exterior, and also use as ceiling tiles for drop ceilings. So we don't use it for hard heavy construction or structural buildings. So that's why we chose doors and ceiling tiles and exterior, and use it for exterior.
Okay, Albina, thank you so much. Green Access, that is Green Access pitch. We will find out a little bit later on tomorrow whether we'll see you again as one of our winners. But in the meantime, thank you so much. Wonderful.
Thank you.
Really tough, isn't it? Really, really tough. Really to decide who the lucky winners should be. All diverse, all credible. Yeah, it's going to be a real tough decision for our jury members to decide who should actually walk away a winner. We move on now to, guess what, number 10, the 10th finalist of our first part of the competition. Remember, 10 finalists right now, 10 finalists at 5 o'clock, and we find out the winners tomorrow afternoon at 2:30. But for the time being, we go from Lagos in Nigeria on a plane over to Germany. We're back in Germany because we have JEC Connect and the CEO, Lars Malta, with us right now. Are you with us, Lars?
Yeah, good morning from sunny Hamburg.
Sunny Hamburg. Is it often sunny in Hamburg?
Well, no.
Well, that might be a sign. This might be just a sign for everybody. The sun might actually bring you luck right now. We'll see. Your presentation looks ready. You seem ready. Are you ready?
I am ready and looking forward.
Wonderful. 3 minutes, over to you.
So, hello everybody. I'm Lars Malta, the CEO of JEC Connect, and what we aim is to bring hybrid materials, namely steel and composites, together to have the right material in the right place. Because as we all know, to have really hybrid structures is one way to have good lightweight structures, and lightweight is a good way to boost sustainability. So we heard already about the challenge of joining dissimilar materials, and there are two naturally well-known, let's say, ways how to do. One is adhesive, the other one is bolting. And you all know the disadvantages. It's about destroying the composite or having the complexity of adhesives with the certification and so on. And we might think there is another solution, and we develop Faust. And what is Faust? Well, actually, we developed a hybrid fabric. So we interlock metal and reinforced fibers already in a hybrid fabric. So it's a warp knitted scarf where metal fibers and reinforced fibers are interlocked to each other. And the specialty of this, let's say, fabric is it is weldable. So what we create, what is our product, is a connector. It's a connector between pure metal to fiber reinforced plastic via a hybrid weldable fabric. And how does it look like? Well, actually, here we are. It is a connector that can be directly integrated into your composite manufacturing process. So you integrate it into, in this kind, vacuum infusion, and what you receive is a weldable composite, and metal and reinforced plastic are interlocked by the fabric. So this is really the benefit of Faust. So you really have an easy joining process to weld, to create hybrid structures. And this gives you a lot of, let's say, freedom in the design process and also in the development. So our business model is typically to have customized profiles, standardized profiles, and also we can license this. And we are going to market end of this year with the first commercial products, because the market is huge. We all know adhesives are everywhere, and we just want to cut a little piece of that with our latest technology. And we are already in maritime. As you know, we have, for example, lightweight superstructures. Then these can be made from FRP and welded to the metal structure. But we are also looking in other fields. And what we are really looking for with our team is going to other fields and making demonstrations. And please come with us. Thanks a lot.
Exactly. I had, exactly as you finished there, I had a countdown, right, 0 when you finished. So well done on the timing. We'll see how well you did from maybe some of the questions from our jury members right now. So I believe we have Thomas, who has a question for you, Lars.
Yeah, so thank you very much for the presentation. And I guess even if your solution is conceptually universal, so I wonder if you could anticipate any strong need to support your customers on applying this solution at the, let's say, at the shop floor, at the very basic level for specific parts and so on. Would you see that this as an entry barrier?
As I understand, so what we do is, on the shop floor, we can really bring the benefit to a lot of engineering or production companies, because they don't need to handle adhesives, but welding. So this was your question, more or less. Otherwise, we let's say, support our customers by designing the joints, because it's more or less between design of weld and between design of composite, and we have all the knowledge in the company. Did I get it right? Otherwise, please comment.
Okay. Yes, thank you.
Got another 60 seconds on the clock. One more question, perhaps?
Yeah, maybe, Lars, how do you manage the thermal expansion, mainly of huge components?
Yeah. So typically what we do is we machine down the metal part and fill it up with the composite. So we really go down with the properties and have a smooth transition between the metal and the composite, which gives not a harsh, let's say, forces if you have the thermal extension. Also the hybrid fabric, which is not metal glass fibers, has a transition part into that. So you have really always a smooth transition from one material into a hybrid into another. And this is quite beneficial for such thermal loading.
But do you have a specific resin in that transition area, or is it the basic resin that you're using for your structural component?
Depends. We can typically use epoxy, which is also in maritime offshore wind. We can also make modified with elastomer epoxies if you need really tough environmental conditions between -30 and +80, for example, and really protect that. Besides, we are quite flexible, so we can also bring elastomers, stripes, press it on here to really protect also the composite and metal interactions. So the Faust technology is quite, let's say, open also to add with other technologies to make a whole joint design towards your needs.
Lars, thank you so much in sunny Hamburg. Hopefully it brought you luck. We'll see a little bit later on, but thank you so much, and maybe we'll see you as one of our finalists. Thank you.
Thanks a lot.
Wonderful.
Bye-bye.
Right, guess what? We have come to the end of this first session, this first 10 finalists. You've heard them, we've heard them, our jury members have heard them as well. 10 big ideas, 10 innovative ideas for the Startup Booster Competition 2021. What happens now is our jury members will already start to evaluate what they've heard. And then a little bit later on, remember at 5 p.m. today, this afternoon, we will hear another 10 big ideas, another 10 finalists out of the 20. And after that, during the evening time, we'll find out, the jury members will evaluate. And tomorrow at 2:30, remember tomorrow at 2:30 p.m., I will be announcing at the award ceremony the three well-deserved, not just lucky, but well-deserved winners of this competition. And as you can agree, it's a tough decision to make. If I was to ask you, who would you choose out of this 3 winners? Who would you choose? Once again, let us know in the chat. It won't influence the jury members, but maybe it will just give us an idea, a flavour of exactly how you're feeling wherever you are in the world. And I have to say right now, thank you so much to you wherever you are. You've probably got a lot of different things to be doing in your lives right now. You decided to spend it with us. We thank you for that. We thank our pitchers, and we thank definitely, naturally, our jury members who've given their time and their knowledge and their expertise to decide who these lucky winners are. We'll be seeing you once again, jury members, a little bit later on, and naturally our partners as well, Daimler, Airbus and Magna as well. If you've heard something you like, you're curious, you'd like to know more, whether it's a winner or not, go over to the Startup Booster Village at the Digital Trade Show. You can join up with them, ask them questions, maybe link up or even on LinkedIn. If you like what I'm doing, link up with me on LinkedIn as well. In the meantime, we'll see you at 5 p.m. And right now, I would ask everybody to come back on the screen. If we can have all our jury members, all our startups as well. And all we have to say now is goodbye and see you at 5 p.m.
Bye-bye.
Bye-bye. Thanks a lot. Bye-bye.
Bye-bye.
Bye.